Math 110 workbook class. We're about starting. So we're given an assignment on Math 110 from our workbook. And the first question the lecturer asks us to solve is on page 2. Page 2, question 2. We're asked to classify these sets accordingly based on the available set notation in the right-hand column. Class, there are different methods of classifying sets. We have the roster method. The roster method, also known as the tabular method. Tabular what? Class. The roster or tabular method classifies sets in such a way that the members of the set are written out outrightly. The members of the set are written out what? Outrightly. We have the tabular or roster method. Class. Examples of tabular or roster method. If you have your manual, you see the E. If you have your manual with me, this is a tabular or roster method. Class, there is no stress in discovering the members of this approach, classification. But class, we have, so we call this roster form, but we have another form called the builder form. Set can also be classified in the builder what? Form. And then set can be classified in the statement form. So we have roster. In the roster form, the members of the set are listed out outrightly. In the builder form, you are given either a bit of algebra or something that you need to figure out before you discover the members. And the statement form, a statement is made that can help you discover the members of the set. For example, class, look at this. Vehicle brands in Nigeria is a statement form. Vehicle brands in what? In Nigeria. Names of local government area councils in Rivers State. That's a statement, right? From the statement, you can now discover the members of the set. But in the builder form, they don't give you the members of the set outrightly. They don't give you the members of the set what? Outrightly. So let us classify each of these sets. Either our answer will either be in roster, builder, or statement. Are we together? Roster, builder, or what? So class, with this explanation I'm giving to you, I want to see if you see that you can easily answer this. If you are not with your manual, you can snap someone's manual and so you can be following up. You have your phone. Just snap someone's manual beside you. It's good when you're seeing what they are solving. A. Vehicle brands in Nigeria. Class, which form is this? Statement, right? So class, the answer to this classification is what? Statement form. This set is in statement form. B, the one that says science, engineering, agriculture, and the continued education. Class, what set, what form is this? This is roster. This is what? Because last, there's nothing to find out here again. The members of the set have been given out outrightly. C, any real number divisible by 10. Any real number divisible by what? Class, what will you classify this? Any real number divisible by 10. You can say this is a builder form. This is what? Because class, you be the one to build the set, right? You now have to ask us anything that makes you start calculating. In the statement form, you don't need to calculate, you just need to list out. Statement form is very close to the roster form because it's almost like you know the answer, but they don't just want to mention it, but just give you one statement that will help you to figure out the answer. But class, this is not just a statement. This will require you to think of real numbers first. Require you to think of numbers that are divisible by 10. This is a two-step process of building the set. So we'll call this the builder form. D, a set of x, so that x is what? Z. This Z represents integer. A set of x, whereby x is an integer, Class, when you see this in set, it means is or is a member. X is a member of all integers. Z means integers. Z is a symbol for integers. And such that this symbol stands for such that X is greater than or equal to 0 and X is less than 10. This is clearly a set builder. This set class, this is a builder form because let us denote this set. In fact, let's denote these two sets, C and D. Let us build the members of this set. Because class, you could be asked to represent this set in roster form. In roster form means that you should list out the members. Let's find the members of these two sets. Set C, any real number divisible by 10. Divisible by what? Who are the real numbers that are divisible by 10? 1. They are just simply asking for the factors of 10. Factors of what? Numbers that 10 can divide them without any remainder. 1, 2, 5, and 10 itself. 10, 8. Class, these are the members of this set C. All these numbers are divisible by what? 10. Any real number divisible by 10 means that leaving no remainder. Leaving no remainder. Now, let's look at set D. Class, they do not ask us to list out the members. I'm just going ahead to do it. No, now, please. Set D, we have a set of X, so that X is a member of all integers. Class, integers can be positive, it can be negative. As long as you're a whole number, you're an integer. In mathematics, as long as you're a whole number, you could be positive, you could be negative. So minus 100 is an integer. Minus 200 is an integer. But once you are not a whole number, you're not an integer. It means decimals cannot be integers. Fractions cannot be. You must be a whole number. So class, X is all integers, but X must be greater than or equal to 0. And X must be less than 10. Greater than or equal to 0 means 0 is among. So this means that 0, 1, 2, till 9. Till what? These are the members of set D. So they do not ask you this, so I'm just trying to make you understand this the more. They do not ask for this. I'm just trying to make you understand the more. Class, the numbers of this set is 0, 1, 2, 3, 4, 5, 6, 7, 8. You stop at 9 because they say X must be less than 10. They do not say less than or equal to 10. Less than 10. Now, E. A-E-I-O-U. This a what? Roster, right? This roster, clearly. This roster form. Because we have to classify each of the sets into roster, statement, or builder form. F. Odd numbers divisible by 2 and 3. Odd numbers divisible by what? You have to build this set, right? What are the odd numbers that are divisible by 2 and 3? You have to ask yourself, what are odd numbers? And class, this set is very big. There's no limit. Odd numbers that are divisible by 2 and 3. There are a lot of odd numbers that are divisible by 2 and... Okay, let's not say there are a lot, but there are quite a few. 6 is divisible by 2 and 3. 6 can divide 2, can divide 3. 12. Odd numbers. Okay, odd number. 6 is not an odd number, it's true. Okay, they are not that much. Odd number. 6 is an even. What are odd numbers? That's this interesting question. What are odd numbers that are divisible by 2 and 3? 9 cannot divide 2. Don't be too fast to say empty set. Oh. It doesn't have any limit. That means even one big number above 100 can be there. You will not know. It's very rare to assume that there's no number that can divide 2 and 3. You say? 21. No. 21 cannot divide 2. Let's keep thinking. Yes. Don't say there's 42. 42. Odd numbers. Odd. Sorry. I retract my statement. Someone said 18. 18 is an even. Interesting. Class, this is therefore an empty set. Empty what? Why is something telling me that there might be a number? Odd. But it's going to be difficult. Okay, it's going to be difficult. You know why? There's no odd number that can divide 2. There's no odd number that can divide. Do you know that, right? that numbers that are divisible by 2 should be even. It's true, it's an empty set. You see? Set. Now let's go to G. It's a builder. You see, we have to build the set now. Are you not saying that you have to G 1, 2, 3 till 9. This one is what? Roster, right? Please snap someone's manual beside it so you can be following up what's going on. You will understand better if you are seeing what we are solving. You can use your phone. Everybody has phone now. Just snap someone's manual beside you, even if you don't have your own manual. It will make it easier for you to correlate. There's a big difference between someone that is just following with blank head and someone that is using direction. Okay, so this is what they are doing. Okay, this is what they are. Snap someone's manual beside you. It's simple. Don't say I don't have manual. You now relax. Just snap someone's manual beside you. Let's look at I. State deputy governors in Nigeria. Statement, Abi. J. All prime numbers divisible by 2. Builder. All prime numbers divisible by 3. Builder form. What's the next assignment? What's the next assignment? Number what? Page 8. Where's page 8? Number what? Page 8, number 3. Page 8, number 3. Page 8, number what? 3. Follow me. No, nice. Page 8, number 3. I've answered it here now. Ask anybody around you. Hij. H is, if you have been following this, you shouldn't be asking me yourself. State governors in Nigeria, statements. State deputy governors in Nigeria, statement. All prime numbers divisible by 2, builder. All prime numbers divisible by 3, builder form. The last 2 is builder, the other 2 is statements. Yes. I'm waiting for calculation here. Let's calculate now. Number 3 said, if a set of x such that, this symbol stand for what? X is greater than 5. And B is a set of x such that 7 is less than x, x less than 15. And C is a set of x such that x greater than or equal to what? 5. And D is a set of x such that 7 less than or equal to x, x less than or equal to 15. Interesting. Then we shall have to find A union B. A union. They ask us to find a lot of things. But class, before we start finding those things, let me bring out the real members of A to D. Let me bring out the real members of A to what? D. So it will help me to figure out what to do. A. X must be greater than set of A, X, so that X is greater than 5. Class. The set of A is all numbers from 6, 7 till infinity. Class, this is an infinite set. This is an infinite because an infinite set is a set that has no ending. That means you can keep going. There's what we call finite and infinite. Finite and this is an infinite set. Because class, there's no boundary at the other end, right? Yes. I believe I saw when lecture teaching you inequalities, intervals. You know, you have open and close, right? Open and when you will draw your this thing like this. Is this one open or closed when you see this sign? This is open, right? But when I shade it is what? I'll teach inequalities. Remind me, I'll teach inequalities in this class. I'm sure some of you may be lost in the lecture in this topic. I'll teach inequalities in this class and how to represent them on the graph, on the different types of inequalities and how to also represent them. Let's just finish this workbook. Now, class, this set A, set B. This one has a boundary. This is a finite set. So, 7 less than x means x greater than 7. Class, follow me. Follow me carefully. If they say 2 is less than 3, can we say 3 is greater than 2? Because this set has 2 statements. 7 is less than x and x is less than 15. Let's pick the first part of this set, 7 less than x. If 7 is less than x, does it mean that x is greater than 7, class? So we can say, because it's easier to understand numbers that are greater than 7 than to understand numbers that are less than x. Because we don't know who is x. We don't know who is. If you say, okay, 7 less than x. If you take this statement like this, who is x? No, you don't. So switch to the other side. If 7 is less than x, it means x is greater than It's easier to know numbers that are greater than 7, right? What are numbers that are greater than 7? 8, 9, right? But if I ask you, what are numbers 7 less than x? Tell me. You don't know who is x, right? So you cannot tell me the numbers that are 7 less than. So anytime you see a problem like this, switch it to the other side. If 7 is less than x, tell yourself, okay, it means that x is greater than. What I mean is, if 2 is less than 3, it means you can say 3 is greater than 2. If 2 is less than 3, we can say 3 is greater than 2. So if 7 is less than x, it means x is greater than 7. Now, so x is greater than 7 but less than 15. But what? So we're looking for numbers that are greater than 7 but less than. So set B is 8, 9, 10, 11, 12, 13. Class, these are the set B. This set. Set C. X must be greater than or equal to 5. So starting from 5 to infinity. This is a finite set too. There is no ending of the set, right? All numbers that are greater than or equal to 5, they are much. And set D. Where's set D? Set D is almost like set B, just that now it's equal to here and equal to here. So 7 less than or equal to x, switch it just like we usually do. Switch it. If 7 is less than or equal to x, it means x is greater than or equal to. If 7 is less than or equal to x, it means x is greater than or equal to 7. But x must be less than or equal to 15. Now, because of the equal to there, 7 and 15 will be included this time around, right? So set D is what? 7, 8, 9, 10, 11, 12, 13, 14, 15. This is set D. Class, why is it important to bring out the members of the set before you start solving the main question? So that it will be easy. If they say A union B, you know who you are uniting with who, right? If they say intersection this, you know what to do. But if you have not brought out their members, it will be more difficult. It will be more what? Difficult. Those that are going, I believe it, maybe you have practicals, right? Hello? You have practicals now? Practicals. Don't worry, it's recorded. So you see the importance of making sure that you're on our registered members group class. The full class we did yesterday on Math 120 differentiation. Our students have it already. Those that have registered with us, we have a separate group apart from our general group. Apart from our general group, we have a separate. So those that have registered, we're able to have access to the class. Like they have practicals now, but because it's being recorded, they have the backup, right? So there's a reason why we are doing this recording. Don't think I'm enjoying it. It's stressful. But I have to do it because of everybody's schedule is not the same. Now, some people, we still have Math 110 tomorrow by 3 p.m. You might check now, some people are not even free tomorrow by that 3. They have practical or something. So you see, why this assignment is very long. So we'll do some today, we'll do some tomorrow. Anyone you miss, register with us so that you can have exclusive access to the class. Now, class. So let's solve the first one. A union B. A union. A union B. Class, when unifying two sets, it means join the members of the two sets together without repeating any of them, without any repetition. When unifying two sets, you are joining the members of this set to this set, but without any repetition. What do I mean by without any repetition? Class, set A, does set A have 9? Is there 9 in set A? Yes. Because set A is 6, 7, 8, 9 till infinity, right? Set B also has 9, right? So you want to join set A to set B, you will not mention 9 twice. Once you have mentioned 9, you have mentioned. So A union B start from set A, 6, 7, 8, 9, 10, 11, 12, 13, 14 till infinity. Till what? Why do we say till infinity? Because the set A is till infinity. So if you are joining a member of set A to B, you must mention the set members of A and all members of set. And members of set A can enter one bracket, right? Because 6, 7 till infinity. I hope I'm good there. So class, you say A union B, 6, 7, 8, 9, 10, 11, 12, 13, 14. Till is A union B. Is A union what? B. A intersection B, the second part of the question. Intersection means what is common between the two sets. What is common between the two? Class, what is common between the two sets? We start from this 8, 9, 10, 11, 12, 13. Because everybody in B is in A, right? But this 6 and 7 is not in B. Because B did not start from 6 and 7, it started from intersection between two sets are elements that are found in the both sets. Elements that are common in the both. So 8, 9, 10, 11, 12, 13, 14. Number 3, A minus B. Class, this difference between two sets. I've taught this if you were in my set class that time, January, I taught difference, right? I've taught difference between two sets, A minus B. What's another sign you can see if you don't want to use this sign? What other sign can they use? Slash, right? I've taught it in normal class before. I've actually finished set in this class, but I'll teach it again. Because when I did it then, we have not started recording, so I'll do it again so I can have the record of it. So those that are joining can still access the class. A minus B means subtract B from A class. Let me use a simpler example to explain it, class. So you also understand this. In fact, it's like I'm teaching set already now. I'm solving, I'm teaching, right? This manual also makes you know the topic because each topic in this manual is in your scheme of work normally, right? So you are learning. A, let's say set A is 2, 3, 5. I'm using a simpler example. And set B is 1, 2, 4. And someone says you find A minus B. Because the difference between two sets, you must recognize the primary set and the secondary set first. Because the primary set is the first set mentioned. Secondary set is the second set. Because class, you're going to subtract the set, all members of the secondary set from the primary set. When looking for A minus B, when looking for a difference between two sets,